This is going to be the first of our maths recap lessons. I'm going to start by recapping decimals, which is going to need a little bit of talking about fractions first. Now, I would just like to say before we go any further, I know a lot of you have been finding decimals hard and fractions hard. Please don't worry. This happens every year. This is the hardest bit of Year 4 maths. It's the bit that everybody always finds tricky, and it will be done again in Year 5 and Year 6. It's not because of you. It's not even really because of the lockdown, although it hasn't helped. This is always the bit that gets tricky. It's always the bit that we have to recap at the end. So, let's have a look at what it is we actually need to recap. These are the things from the national curriculum that I want to cover pretty much today. You need to be able to count up and down in hundredths. If you can't count in it, you probably don't understand it, which means you need to get that bit sorted first before you go any further. You need to understand that hundredths arise when you divide an object by 100, and that dividing it by 10 gives you tenths. You need to be able to write and recognise decimal equivalents to any number of tenths or hundredths. You need to be able to find the effect of dividing one or two digit number by 10 or 100. That bit we might not do today. This bit might wait for another day. And you need to compare two numbers with the same number of decimal places up to 2 decimal places, and that's important. You are in Year 4. You need to do 2 decimal places. Let's just go back to this page for a second. There's some very specific sets of numbers you need to be able to work with in Year 4. You need to be able to go with numbers up to, one pen, work, 9,999.99. That's the kind of limit of what you need to be able to do for Year 4. Now, I know that most of you know about 10,000 and 100,000 and a million, and to be honest, once you've got the pattern, it kind of goes in both directions quite easily. But to actually have to worry about, well, not have to worry at all, but the things that you need to be able to do are numbers that are that big. Now, before we go any further, we need to do a little bit of recapping of what a fraction is. I think most of you have got a pretty good grasp of what that says. That says a quarter. It's something that's been cut into 4 pieces, and you've got one of them. Shape, been cut into pieces, and you've got one of them. The numerator at the top, denominator at the bottom. Sometimes you might not have a unit fraction, you might not have one at the top. You might have more coloured in, you might have 3 quarters. That means the shape is still cut into 4 pieces, but you've got 3 of them. Now, this was a bit of fractions that I think most people are quite secure in, so I'm not going to spend a lot of time on this. For the sake of today, we need to be thinking about things that are cut into tenths. There's going to be no quarters, no halves, no thirds, no eighths, nothing like that. We're going to be thinking entirely about cutting things into tenths and cutting things into hundredths. And if you don't get the tenths bit, don't worry about the hundredths bit yet. We might have something like 4 tenths, but that's about as complicated as it's going to get. So we'll have an object, and we're going to cut it into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 tenths is 1, 2, 3, 4 bits of something that was cut into 10 bits. 4 tenths. But we're going to write them as decimal numbers, or decimal fractions. So, let's go to here. Let's think about an actual thing. Let's think about a chocolate brownie. Now, ever since you learned to count, ever since reception, you've understood that you can have 1 of something, you can have 2 of something, you can have 3 of something, 4, 5, 6, 7, 8 and 9, and you've got digits to represent those. But eventually you run out of ways of writing numbers at 9, and then you've got a problem. If you've got 10 chocolate brownies, you have got, well, you've just got no more symbols to write the number 10 in. So we have a ones column, but we also have a tens column. You could take 10 chocolate brownies and put them in a packet. So after 9 comes 10, one whole packet of chocolate brownies and no more. Now you can keep on counting: 11, 12, 13, 14, 15, 16, 17, 18, 19, which would be one packet of chocolate brownies and 9 individual ones. But then you can't fit anything else in this place. So again, we have to roll over and we'll have 2 whole packs and no brownies. We have the number 20. This can keep on going, and this digit can get too big, but you can take your packets of chocolate brownies and put them into a box of 10. This is my 10 packets or 100 brownies in that box. This is my hundredths column. This is all things that you know how to do. So I could have the number 364. That is 300 brownies and 60 brownies and 4 brownies. 3 packets of boxes of 100, 6 more packets of 10, and 4 more individual brownies. I think most people are happy with this. But things can get smaller. What if someone's so stingy they don't give you a whole chocolate brownie? Here's my chocolate brownie. But what if I don't want to give you all of it? What if I want to cut it up? I'm going to cut it up into tenths. Now I could sit here spending an absolute age, that's a nice light colour, trying to cut this brownie up into tenths like this. But I was lazy and I've already made one cut up. So there's my chocolate brownie, and it's been cut into 10 pieces. I could give you, ooh, I've got that pen sparkly. I could give you 3 of these pieces. You would have 3 tenths. It's a very small amount of chocolate brownie, but I could do it. Perhaps we're making cake decorations or something. I'm going to need to write that down in a minute. Sometimes you might be really so stingy that even that little slice of chocolate brownie is just too much for somebody. I can take my chocolate brownie and I can take one of my tenths. Thank you, pen. This one here, for example. And I can cut that into 10 individual pieces. We now need 100 of these to make up a whole brownie, so they're called hundredths. That is now a very tiny piece of brownie. You might almost use it like sprinkles on top of a cake or something, or to mix into ice cream. It is absolutely tiny. You need 100 of them to make a brownie again. So this here is 1/100th, or I could give you that, which would be 5/100ths. What I could also do is give you, let's say, all of that and that bit there. I'm giving you 10, 20, 21, 22, 23 hundredths, or 2 tenths, because these are still tenths, and 3 more hundredths. Using this fraction notation gets a bit complicated. Don't particularly like it. So let's use the nice, neat decimal notation. And to do that, we can have a nice tens frame. Not tens frame, place value frame. Goes up far past tenths. Okay. Here we've got the most important place, the ones place. This is where we write anything between 1 brownie and 9 brownies. I can put 1, 2, 3, 4, 5, 6, 7, 8 or 9 in that place, and that will mean 1 brownie, 2 brownies, 3 brownies, all the way up to 9 brownies. This is my 10th place. This is where I put packets of 10 brownies. This is my 100th place. This is where I put boxes of 100. And because you're year 4, you need to be able to go up to 9,000. We could have a big packing crate that's got 10 of these in. Okay? So this is my thousands place. So if I had 4 big boxes, 6 smaller boxes, an extra 3 packets and 2 brownies on their own, I would have 4,632 brownies. 4 of these, 6 of these, 3 of these, and 2 of these. Let's see if this rubber works. Yay. Now that's just place value, and I think we're all pretty good at that. We need to think about this. Well, tenths just has its own place. It just has a place to the right of the ones. And we put this in to show us. Otherwise, if that wasn't there, people might look at a number and not realise that the last place was tenths. They might just assume it was ones. So if I said I'm going to give you 2 whole packets, 3 individual brownies and 2 slices of brownie, if that place wasn't there, that would look like 232. It's not. It's 23 whole ones and 2 tenths. I could also be really stingy and give you tiny bits, like 4 hundredths. You've now got 2 packets of brownies, so 20 brownies, and 3 individual brownies, and 2 tenths of brownie, and 4 hundredths. So let's have a pen that's less sparkly for a minute. Black pen. Okay, so 1/100th goes there, and we'd need something here. You always need to have something in the ones column. Even if it's empty, we just put our placeholder 0 in. That says 1/10. That says 2/10. That says 3/10. And we can keep on counting up into tenths. When we get to 9/10, that's the biggest we can get. And then we need 10/10. Well, 10/10. You don't get 10 in one place. What we are not allowed to do is cram 10 in there. You never do that. You always go over to the next place up. So just like when we've got too many ones, we get a whole packet. If we've got too many tenths, what we've done is glued a brownie back together again, or sort of squidged it back together again. So after 0.9 comes 1 whole one and no little bits. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, or 1.0 if you wanted to write it, but 1 whole one. And then we'd have 1.1, 1.2, 1.3, all the way up to 1.9, and then we'd have 2. And it would keep on going like that. Hundredths are no different. They're just 10 times smaller. We can have, let's get rid of all that along the bottom actually. We can have 1/100th with no 10s, no 1s. We can have 200ths, 300ths, 400ths, 500ths, 600ths, 700ths, 800ths, 900ths, but we're not allowed to have 10/100ths. You can't have 2 digits in one box. That becomes that. That's what 10 hundredths look like, because 10 hundredths is just a tenth. Now again, we don't need to write this, but it doesn't hurt if you do want to do it. In fact, your year 4, the numbers that you're going to write are only ever going to have 6 possible digits, so I'd be tempted, certainly later on when you're comparing numbers, to think of everything, let's have a nice grey, as being made up of 6 digits. And then you just write your actual number over the top. So 43 is no thousandths, no hundredths, 4 tens, 3 ones, no tenths, and no hundredths. .37 is no thousandths, no hundredths, no tens, 2 ones, 3 tenths, and 7 hundredths. 40.06. That's 4 tens, no ones, no tenths, and 6 hundredths. 236.5. That's no thousandths, 2 hundredths, 3 tens, 6 ones, 5 tenths, and no hundredths. Sometimes it's worth just imagining that that 0 at the end is still there. Makes it easier to compare things. Now, I have done 4 sheets for you to try. There's no point rushing through this. If you don't understand it, you need to kind of stay at the first stage. I can show you videos I found on YouTube that you can go and watch, and other things that you can try and do. But to begin with, you just need to be able to count in this. Now, the first sheet I'm giving you looks like this. This is one, let's have a nice sparkly pen again, 1 whole brownie. Except it's not a whole brownie because it's not coloured in. You've only got the grey bit. What you've got here, and there's 2 ways we can look at this. We could either say, well, I have got 1 slice, that's a tenth, 2 slices, 3 slices, so I have got 3 tenths. I've certainly got no whole brownies. And then I've got 1, 2, 3, 4, 5, 6, 7, 8 hundredths. So I could say my answer is 0.38. There's another way of looking at it. I could literally just count my hundredths. And I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. There's 38 hundredths there. Well, I can't write 38 in the hundredths box. You're not allowed to do that. So that 3 is going to have to move over into here. And now look, I get 0.38. I get exactly the same number. So with this second one, I can either count the tenths, 2, 3, 4, 4 tenths, and then count the hundredths, 3 hundredths, 0.43, or I could count the whole lot, count them all individually. I would find there's 43 of them, and I'd still write it as 0.43. That would be the same thing. After 0.43 would become 0.44, 0.45, 0.46, 0.47, 0.48, 0.49, 0.5, 0.51, 0.52, 0.53, 0.54, 0.55, 0.56, 0.57, 0.58, 0.59, 0.6, 0.61, 0.62, 0.63, 0.64, 0.65, 0.66, 0.67, 0.68, 0.69, 0.7. And you can keep on counting up, and I actually would suggest that you do practice just counting up on that grid. If you can count in hundredths, we're mostly there. So that's your first sheet, that's your first task. If that's too tricky, practice counting in hundredths, practice counting in tenths. If that's fine, it's something to be going along with. But we can also try this. This is where you need to tell me the place value of a specific digit. So, which digit is in the ones place? Well, this number is 96.37. 96.37. This decimal point helps us line up where these digits go. Which digit is in the ones place? Well, that one is. So the digit is a 6. That's all there is to that one. Next one, 57.92. Well, the decimal place is there, and I know the 7's one side of it, and the 9's the other, and the 5's there, and the 2's there. My number is 57.92. Which digit is in the tenths place? Well, it's this place, so it's 9. Let's do one more of these. 91.54. Which digit is in the ones place? That place. The digit is a 1. Okay? Hopefully not too tricky. Okay, next one. You have to write out each number in a kind of long expanded form, like if you're doing expanded column addition. So let's do one as an example. 18.19. That is. Now, if I was writing this out entirely, I would write out no thousands, no hundreds, 110, 8 ones, 1/10, and 9 hundredths. It's perfectly fine to write that, but we're kind of lazy as humans. We're not even going to mention this one because it's empty, and we're not going to mention this one because it's empty. So we're just going to write out 1, 10, 8 ones, 1/10, 9 hundredths. Okay, the next one's a bit bigger. It is 8, 5, 6, then there's a decimal point, and then 2, 6. Going to need to write a bit smaller for this one. Here we have 8 hundredths, 5 tens, 6 ones, 2 tenths, 6 hundredths. Final one on this page, we've got 19.24. Nothing here, so we're not going to mention it. Nothing here, so we're not going to mention it. We've got 1, 10, 9 ones, 2 tenths, 4 hundredths. We're doing this sheet so that I can tell that you know, and so that you know that you know, what each of these places actually means, so that you really, really know that this is tenths, that is much smaller than the ones, and that this is hundredths, and they are tiny compared to the ones. If you can do that sheet, I've got one last one to try. This is comparing digits. Now, when we look at the national curriculum, that last point we had to do was was to compare numbers with the same number of decimal places up to 2 decimal places. Compare in a maths world means greater than, less than, or equal to. It's only going to be 2 decimal places, and they've got to have the same number of decimal places. So I'm not going to be nasty and give you something, well, actually I have. I've done it there and there. You almost have to imagine the extra decimal place in there. Okay? If you want to, you can just totally avoid anything where the decimal places, number of decimal places don't match. But I don't think it's too tricky just to fill in the extra 0 at the end. So 5.92, 5.92 and 6.02. I've made sure that all my columns, if one's got something in it, they both got something in it. Same number of decimal places. Now, I need to decide which one's bigger. Well, I start by looking at the thousands column. Well, they've both got nothing in it, so that doesn't help. Then I look at the hundredths column. Well, they've both got nothing in it, so that doesn't help. Then look at the tens column, and they've both got nothing in it, so that doesn't help. Now I look at the ones column. Aha, one's got 5 ones, the other one's got 6 ones. 6 ones is more than 5 ones. It's the biggest one, it's the direction the mouth points at. Hang on, did I set that right around? 6 is bigger than 5. 6 is the biggest one, it's the direction the mouth goes. Okay. Next question. .07, 4.07 and 4.7, but I'm going to put the 0 in so that the columns match. If one's got something in it, they've both got something in it. I can go and fill in all of the gaps if I want to. Hey, zeros for everybody. And again, I start on the left hand side. Thousands, well, they've both got nothing in it, so that doesn't help. They've both got no hundreds, they've both got no tens. They have got something in the ones, but it's the same, so that doesn't help. Aha, tenths. Well, the first number's got no tenths, and the second number's got 7 tenths. And even though tenths are tiny, tiny slices of cake, having none of them is less than having 7 of them. So 7 is the biggest number there. So 4.7, or 4.70, is bigger than 4.07. So the hungry mouth points towards the bigger number. It gets the more chocolate brownies. Okay, 5.6, 5.6. Let's just fill in at least that space, but let's just be cheeky and just fill them all in. And 5.06, 5.06, and let's just fill in all of our blanks. Okay, they're the same doesn't help, they're the same doesn't help, they're the same doesn't help, they're the same doesn't help. Aha, our first difference. 6 tenths is bigger than no tenths, so our first number is bigger. Our hungry mouth points towards the first number. And then finally, 0.1 and 0.1. Let's just fill in all the gaps. Okay, they're the same, doesn't help, 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 and they're the same, it doesn't help. Well, they're the same number, which means we put the equals sign in, because equals means the things on either side of me have the same value. They are in effect the same. So let's go back up to our national curriculum and use it as success criteria. We're not worrying about that today. So the first thing you need to check you can do is, can you count up and down in tenths and hundredths? Can you have a look at this sheet recognise the numbers, and then perhaps just keep on counting them like I did. Thank you, Ben. Do you realise that you get the hundredths when you divide an object by 100 or into 100 pieces, and not the same as dividing tens by tenths? Did you realise that we took our brownie, we cut our brownie into 10 pieces, and then we cut those tenths into 10 pieces, which is basically the same as cutting all of it into 100 pieces. 10 of those, 100 of those. If you get that, we've got that. Can you recognise and write decimal equivalents to any number of tenths and hundredths? We did that from pictures. We haven't really done that from this sort of thing. We might recap that later, but I don't think many people have a problem with that. And then the last thing we did was this comparing numbers. Can you take two decimal numbers and start from the left hand side and compare them? Now, I like to fill in all the digits up to thousands. Right, no thousands, no thousands, no hundreds, no hundreds, 4 tens, 4 one. Hang on, those are hundreds. Start again. No hundredths, no hundredths. No tens, no tens. 4 ones, 4 ones. 3 tenths, 6 tenths. 6 tenths is biggest. Big open mouth. Have a go at these sheets. If I've still gone too fast, if this is still not recappy enough, or it's too recappy and not teaching lesson from the beginning if that's a word, enough, let me know, and we'll go back and we'll do it a little bit slower and we'll do some more. It's not a problem. If this is actually all fine for you, I've got some other things that you can have a go at next week, so that you're not just watching the same old thing again if you're getting a little bit bored of it. Okay, let us know if you've got any problems.